Hi guys, welcome to Google Cloud Bigtable. So what is Google Cloud Bigtable, you may ask? Um, Google Cloud Bigtable is a fully managed, scalable NoSQL database for large analytical and operational workloads. And it is designed as a sparsely populated table that can scale to billions of rows and thousands of columns, enabling you to store terabytes or even petabytes of data. Mm, Bigtable is a key value store that supports high read and write throughput at low latency, supporting millions of requests per second. So what should Bigtable be used for? Is it used for low latency, fast access to big data, and at least 1 terabyte and data element of less than 10 megabyte? Since Bigtable is not a relational database, so no SQL or multi-row transaction, it won't be a fit choice for online transaction processing. There are some good use cases of Google Cloud Bigtable. So I have identified the two big advantages. First is map reduced operations, and the second one is real-time analytics. For map reduced operations, we have with Cloud Data Flow or Cloud Data Block with Apache, Hadoop, or Spark, HBase API. And for real-time analytics, we have financial services, Internet of Things, and others. And it's not for interactive with SQL queries. We use BigQueries. So we have here is pricing comparisons. So now I compared Cloud Data Store and Cloud Bigtable. Both of them have monthly storage. However, Cloud Data Store charges based upon on reads and writes, and Cloud Bigtable charges upon on cluster. Therefore, Cloud Data Store is cheaper for small data or infrequent access. And Cloud Bigtable is cheaper for big data and frequent access. And because there's no actual installation, since Google Cloud Bigtable is a cloud, to access Google Cloud Bigtable, first of all, we have to sign up for Google Cloud. And what you need to do is that you simply Google Cloud Bigtable right here and click the link as shown in the PowerPoint. Now, after you click the link, it brings you up to this page, and you want to click on Try Google Cloud Free. Next step, you want to enter your country and the purpose you want to use this cloud. So in my case, my countries I identify as United States, and my needs right now is for personal project. And the next step is that you have to enter your phone number because Google wants to verify your identity. And here we come the last step for signing up Google Cloud account is that your credit card information. But do not worry about being charged. Google will not charge you after the free trial unless you decide to upgrade to the full version. And Google asks for a credit card when you sign up for the free trial because they want to use this payment information to verify your identity and to distinguish actual people from robots. So go ahead and put your card number. You won't get charged. And so after you enter your credit card information, you will be brought up to this page, and the free trial provides you with free cloud billing credits to pay for the resources used while you learn about the Google Cloud. So now you have like $300 in credit to spend over the next 90 days. And Now is the fun part, how to use Google Cloud Bigtable. And so to use Google Cloud Bigtable, we create an instance and then set up your development environment to access Cloud Bigtable so that you can add data and monitor performance. Right now on the Bigtable page, you select the create instance. Under instance name, you type homework 5 instance, and this should auto-populate the instance IDs for you as well. The next step is that you select your storage type. You select SSD as your storage type. There are two storage types right here. One is SSD and the other HDD. SSD is the lower latency and more rows read per second, and it's typically used for real-time shopping use cases such as app shopping and mobile app recommendations. And HSD is for higher latency for random needs, for random reads. Good performance on scans and typically used for patch analytics, such as machine learning or data mining. And for the region, you want to select a region that near you. And in my case, I select US West 4 Las Vegas, and I put NA as my zone. Then you click create to create the instance. Once the instance has been created, you then can activate Google Cloud cell in the upper right-hand corner, as shown here. And yeah, this is the finish of the Google Cloud Bigtable installation. And so for the next few sections, we will go over the basic usage, use cases, industrial adoption, limitation in detail, and the comparison between Google Cloud Bigtable with MySQL, Mongodb, and Neo4j. And enjoy!
So, onto table initialization and reads and writes. First, in order to create a Bigtable instance, you just do this. We already have an instance set up. We already have all of these. We already have the CBRT file, and we can create a table. You can even use pre-split tables through this. And families can be created with these commands, just cbt create family, table name, family name. I'm going through this quickly because it's also integrated in our programs here. And table queries will look a little bit like this. CBT, you can use ls to list the tables. You can list the column families within a table through this CBT ls table name, and to delete a table, CBT delete table table name in the same console that we were using last time. Now, finally, we are going to look at writes. Now, writes are complicated in terms of if you use Java. If you use Ruby, which is something that Bigtable makes a lot simpler, the programs are a lot smaller. So we're going to focus on that. And don't worry, the syntax is pretty simple. For writes generally just put data into the table. There's 4 types of writes: simple writes, increments, appends, as in incrementing data, putting data at the end of already existing data, conditional writes, as in putting data in certain spots that already fulfill a condition, and batch writes, which are basically just big multi-line writes. And then there's also reads, which are basically queries, getting data from a table. There are single row reads in terms of just requesting a single row. There's scans, filtered reads, as in sort of like conditional reads. And there's multi-line reads as well. You can go to cloud.google.com in order to see more information about this. What I want to focus on is just some simple programs. So this uses Ruby. Right here, we are in the editor. We were in the terminal earlier, but you can easily open the editor by clicking the Open Editor button. and you can use file, new file, and then create a .rb file to make a simple Bigtable file. Now here's a simple write. This is what a simple write looks like. We already know that the instance ID are going to be basically what we have already figured out and even saved in a file previously. And we create a table through simply doing this. We don't have to go through the other stuff. We can just use this. And we can even just simply use a column family or create a column family here. And remember, each cell is time-stamped. So we have to initialize what a timestamp looks like. In this case, here's just an easy algorithm for timestamp. And we are going to make a easy table of phone numbers. We're going to write phone number entries, use the new mutation entry command in order to do simple writes. And we are just going to set cells to the column family that we set up. The connected cell is going to be the name of it. And we're going to set the timestamp. Remember, each cell needs a timestamp to simply timestamp. And you also need to make sure that you also get the mutate row done. Now that's a simple write. For a batch write being a larger write, you use batch writes for whenever you're writing a lot of information, not just a little bit, just a lot of it, or a lot of information. It'll look a little bit more like this. We are going to have basically the same syntax, but we're also going to append the mutation to an entry array. And then at the end, we're going to have our results equal the entries in here. So we are going to make all of these entries individually mutate the table. So within here, we're going to have a lot of mutations. For reads, it's a little bit less complicated. You're simply going to set up to see, oh yeah, like here's my Bigtable with the instance ID and table ID, and you set up what row you want to read. Say you want to read this row, as in this very specific phone combination. You can simply set that to a variable and print it out. This is a single row read, as in you're reading one single line. For a multi-row read, we're going to be doing the same thing, but this time within a loop, as in for each, in this case, for each phone combination within this array, we are going to read them. Hi, my name is Micah Collins, and today we're going to be looking at Google Bigtable in terms of basic usage, basic commands, and generally how the table works in terms of its rows and its columns. So given that you already have an instance created and you're in the Google console, we can look at the Cloud Shell right here. Let's just activate that. And here's the terminal. Right here, we can see our project ID. And if we're still on this page, we can see our instance name. My instance name is class-instance. And my project ID is nth-silo-331221. Both of these are very important to know. So we're going to go ahead and make a .cbtrc file with both of those in there. Now we can do this by using the echo command. We'll say echo project equals, and then we're going to put our project ID nth-silo-331221. And we are going to route this output to a local .cbtrc file. And next, we're going to append the instance name. My instance name, once again, is class-instance. Let's append that to the same file. And just to make sure it worked, let's also read the file. There you go. We have project name saved as that and instance name saved as that. A couple other basic commands include being able to see our project ID, assuming that you can't already see it, or the Google account actually. Gcloud authentication list, or Gcloud auth list, will show what credential account I'm using currently. In this case, the micah10man@gmail.com account is what I'm actually using right now. Now, before we go into table creation, let's talk a little bit about just Google Bigtable in general. So Google Bigtable has massively scalable tables, which are sorted by key and value maps. Each table is composed of rows, and each row describes a single entity, and columns, which contain individual values for each row. Each row is indexed by a single row key. And here's something that is unique to Bigtable in comparison to MySQL. Columns that are related to one another are generally grouped together into a column family. Each column is identified by a combination of the column family and a column qualifier, which is a unique name within the column family. Also note, each row and column intersection can contain multiple cells. This means that you can have multiple values within a single intersection of a row and a column. And each cell also contains a unique time-stamped version of the data for that row and column. So because you can have multiple cells, you can kind of have a history of the data within a single cell, which is pretty cool. Multiple cells can be stored in a column for use as a changelog with this. Now, a very big plus of Bigtable, something that allows it to become big without being unmanageable, is the fact that Bigtable tables are sparse. If a column is not used for a particular row, it does not take up any space. This allows for very large table structures. And with this diagram, you can kind of see the columns grouped together within column families like this. You have rows indicated by row keys and multiple values allowed per cell. These are all cells that say have value in them. And then these cells that don't have value, these unused cells, are not using any memory. This means that you can have a lot of columns, and perhaps these columns only have values on a couple rows, and it is not a big waste of space. Now, there's a couple ways to optimize this, right? Bigtable, it'll compress your data automatically, but there's not necessarily any configuration settings. But a couple things to note are that random data cannot be compressed as efficiently as pattern data. Pattern data includes text, such as the page you're reading right now, and compression also works best if identical values are near each other. Now, keep these rules in mind whenever you are using Bigtable. Pattern data, identical values are really good to have close together and are very important to keep in mind if you intend to really make the most out of your Google Bigtable and optimize your performance.
Okay. In this next section, we will be looking at some general use cases in the real world, as well as examples of companies that utilize Bigtable, explain why they use them, and show the limitations that Bigtable has as a product for some companies. So let's begin. So let's take a look at some basic use cases. As we've touched on a bit before, Bigtable is obviously best when applied to situations with high throughput and scalability. We've mentioned those words a few times, throughput and scalability, and I just want to remind everyone that throughput simply means the measure of how many units of information a system can process in a certain amount of time. Meanwhile, scalability is the measure of a system's ability to increase or decrease in performance and cost in response to changes in system demands. Now, of course, both of these are crucial in cloud computing, as the internet is rapidly changing, so we need to have database systems that can adapt to new requirements and reorganize data very efficiently. So, let's examine some real-world examples of how Bigtable could be used. First, we have time series data. The key factor here is that we will be analyzing the changes of one kind of data over a certain amount of time. Of course, we can use it to assess the efficiency of CPU at different times, which is often what a lot of these companies do for their own database systems. But a whole lot more can be done with them. For instance, you could be analyzing weather patterns from minute to minute, and this is crucial for graphing out the changes in our atmosphere for a lot of meteorologists, for example. Now, next we have marketing data. This is often what we talk about for examples in our database class. How do Google advertisements know you so well? How can billions of people's information be analyzed so efficiently? Well, something as scalable as Bigtable allows for that kind of flexibility, especially with its cloud-based network stretching around the world, splitting up tasks and all. This is what we were mentioning previously about clusters and nodes, and about how the networks are in different regions of the globe. It's essentially you're dividing and conquering where this computing is actually happening. Next, we have marketing data. This is often what we talk about. Oh, oops, my bad. Reading the same thing again. Financial data. So, in a world becoming increasingly dependent on making transactions online, the optimization of those virtual stock markets has become all the more important. We often hear about non-fungible tokens, and there is a question of how that kind of data will be stored. What will the future of our banking be? And Bigtable could be a solution for some of these companies. In fact, as we'll look at in a few minutes, Bigtable is already crucial in fraud detection online. So let's look at some industrial adoptions. We can see these applications within Google itself, as of course they've been working on this NoSQL system for years, and it has become very elaborate and basically the core of their entire company. They use it for Google Search, Google Earth, Google Analytics, everything you can think of that's under the Google company umbrella. With it being such an efficient system, Google decided to go public with it in 2015, and since then many companies have implemented it. The company you'll likely recognize best here, of course, though, is Spotify. And now let's look at how Spotify utilizes Bigtable for fast access to big data, improving low latency responses, and really optimizing their music streaming system. So you may know that every year Spotify has its annual Wrapped event, where they give you a personalized playlist of your most listened to music of the year. But keep in mind, Spotify has to do this for every one of their 150 million plus users, which requires you to review potentially thousands of songs for every person for 365 days of the last year. And the number of how much computing power that takes begins to increase exponentially. Now, Spotify hasn't always used the services provided by Google, but since 2016, they've utilized Bigtable to sort of compartmentalize different parts of their data processing, giving them essentially this large reservoir to put data in, get data out, in, out as quickly as possible, and without concern of wasting any empty space with blank columns. As you may recall, we've mentioned those. As Tyson Singer here has noted, engineering vice president for Spotify, Bigtable was used as a remediation tool between data flow jobs in order for them to process and store data in a parallel way. It's sort of a middleman in how this entire data flow works. Now, those kinds of advantages for how Bigtable was utilized can also be seen with fraud detection companies like Ravelin. Now, understanding how fraud detection gets a bit more complicated. But what's most important here is that in order for fraud detection to work in a system, you have to keep track of every client's transaction history. So just like with Spotify, you need an infrastructure with highly scalable tables. And Google's Bigtable offered a good solution to Ravelin with its low latency stability and guaranteed security. This sort of goes back to our real world example mentioned previously of financial data, and it sort of relates to marketing data as well, but this is more so looking at specifically financial transactions on the market. But of course, like any other NoSQL or SQL system, there are still limitations. We've discussed a great deal how Bigtable's ability to handle significant amounts of data is its greatest strength, but the fact that it is purposely designed around this makes it not all that useful for smaller amounts of data. What we can learn from this is that Bigtable shouldn't be your first choice if you're simply tracking data as a small business or if you're a student working on a small project. Not to mention the price tag for using Bigtable can get fairly expensive because it's designed around around big data. As you noticed with Bigtable earlier in PowerPoint when we were installing it and learning how to make an instance, you would notice the price tag would get fairly big depending on how many clusters you had. And this is something that if you're a student and you're trying to get into database management, Bigtable might not be your first choice in trying to learn the environment of how these systems work. It also has challenges to storing individual data that is larger than only 10 megabytes. See, what we've been discussing previously has been relatively simple data, such as maybe weather patterns, finances, music history, stuff that you can give very specific integer information for. However, if you try to upload stuff such as, say, video files to Bigtable, then it would be very inefficient for this because of how much you have to compress a video file to even upload it on the internet. And then it should also be noted that, as the name suggests, Bigtable was not designed around relational databases, such as the ones we've been looking at in class. Likewise, it doesn't directly support SQL transactions, as by definition it is a NoSQL database service. This makes it less compatible with many SQL database systems that might be used for transaction processing, although it's not impossible. And so with these things in mind, it really should be your choice on figuring out would Bigtable be most useful for your company. Do you think you would need relational databases? Do you think you would want to have a foreign key primary key system? Do you think you would need a scalable table at this size, or are you small enough to where you could probably use a potentially different SQL or NoSQL software? And so in this next section, we will be comparing Bigtable to other database systems, and hopefully that will help you figure out in the future, would Bigtable be a good choice for you?
After our introduction of Google Cloud Bigtable, let's compare Bigtable and other SQL and NoSQL technologies. For Google Cloud Bigtable, it's using the primary database model wide column store. Wide column store maps two arbitrary string values and timestamp into an associated arbitrary byte array. It is not a relational database. It's more like a sparse, distributed, multidimensional sorted map. For MySQL, same as what we learned in class before. It's a relational DBMS. Bigtable is cloud-based. It's only available as a cloud service, so you need access to internet to use it. MySQL is not cloud-based only, so you can use it anytime once you have it on your server or computer. The license of Google Cloud Bigtable is commercial. MySQL is open source. Google Cloud Bigtable does not support NoSQL. MySQL supports SQL. Google Cloud Bigtable is supported by C#, C++, Go, Java, JavaScript, and Python. MySQL is supported by C, C#, C++, Haskell, Java, JavaScript, Objective-C, PHP, Python, Ruby, and so on. There is no limitation of server system for Google Cloud Bigtable. since it's cloud-based. You can use it with any system. SQL supports Linux, OS X, Solaris, and Windows. Google Cloud Bigtable doesn't support foreign key, since NoSQL databases do not support foreign keys and do not have the concept of referential integrity. MySQL supports foreign key. Now let's compare Google Cloud Bigtable and MongoDB. The primary database model of Google Cloud Bigtable is wide column store. MongoDB stores data in the form of a document, so the primary database model of MongoDB is document store. In document store, a document is identified by a unique key, which is similar to a primary key in a relational database. Documents are usually grouped in another data structure, such as a collection. A collection could be considered equivalent to a table in a relational database, and a document could be considered equivalent to a record or row of data. Google Cloud Bigtable and MongoDB are both NoSQL, so they are schema-free. Although MongoDB is schema-free, documents of the same collection often follow the same structure. Optionally, impose all or part of a schema by defining a JSON schema. Google Cloud Bigtable doesn't support SQL, but MongoDB can use read-only SQL queries via the MongoDB connector for business intelligence. Google Cloud Bigtable is supported by C#, C++, Go, Java, JavaScript, and Python. MongoDB is supported by C, C#, C++, Haskell, Java, JavaScript, Objective-C, PHP, PowerShell, Python, Ruby, Swift, and so on. Google Cloud Bigtable is hosted. MongoDB requires Linux, OS X, Solaris, or Windows. Neither Google Cloud Bigtable nor MongoDB support foreign keys since they are NoSQL. The primary database model of Google Cloud Bigtable is wide column store. Neo4j is a graph database management system. This database system is based on a graph-like data structure with nodes and edges to model complex hierarchical relations. Each edge in a graph represents an explicit relation. A node represents an entity. A relationship represents how two nodes are associated. Google Cloud Bigtable is commercial. Neo4j is open source. Google Cloud Bigtable is cloud-based only. Neo4j is not cloud-based only. Google Cloud Bigtable is schema-free. Like other NoSQL technologies, Neo4j is also schema-free, but Neo4j is schema optional as well. A schema in Neo4j refers to indexes and constraints. It is not necessary to create indexes and constraints. You can create nodes, relationships, and properties without defining a schema upfront. Neither of them supports SQL since they are both NoSQL. Neo4j supports .NET, Go, Haskell, Java, JavaScript, PHP, Python, Ruby, Clojure, Elixir, Groovy, Perl, and Scala. Bigtable is hosted. Neo4j requires Linux, OS X, Solaris, or Windows. Google Cloud Bigtable doesn't support foreign key. For Neo4j, nodes and relationships are the essential constituents of graph databases, so Neo4j supports foreign key.